Moving now to the concept of future value, and we will start with a simple case where we look at the future value of a single cash flow. The future value at time n is equal to the present value into 1 plus r, which is the interest rate, to the power of n. Say the present value is 100, so at time 0 the value is 100, the interest rate is 10%. What is the future value after 1 year? If you plug into this formula, what you see is the following. The present value is 100, r is 10%, and in this formula we will use the decimal, so 1 plus 0.1 to the power of 1. This is equal to 110. So after 1 year, 100 will compound to 110. What about at the end of year 2? Again, from the formula, we have 100 into 1.1 to the power of 2, and this is 121. So at the end of 2 years, we have 121. We can say that FV2, future value at the end of year 2, is 121. Notice the following. If we only had simple interest, where 100 is invested, then in year 1 the interest would be 10, in year 2 the interest would be 10, and at the end of 2 years we would have 120. So why is there a difference between 120 and the future value of 121 that we have calculated using this formula? The answer is because of compounding. What has happened is, at the end of year 1 we have 110, which is the original 100 plus the $10 interest. That entire amount, the $100 and the $10 interest, is being reinvested for the second year. So in our compounding scenario, even the $10 is receiving interest, and it is the $1 interest on these $10 that is giving us the extra $1 over here. Let's see if you can do this practice problem now. This is fairly straightforward, and here is what you should have done. So recognize the formula that we just saw. Future value is present value into 1 plus r to the power of n. So n here is 2.5. You plug in the numbers, and that is what you should get. Let us now learn how to use the financial calculator, and then we will do a future value calculation using the calculator. The first time you use your calculator, and we'll talk here about the Texas Instruments BA2 Plus, you need to set the floating decimal. And what that means is, when you set to floating decimal, the calculator automatically gives you the appropriate number of decimal places. So you hit the following keystrokes: second, which is right here; format, which is over here; and then enter, which is here. And then you will see the option to enter the number of decimal places. You enter 9, and the display is going to be 9. Then you hit second again and quit. That will return the calculator to standard mode. What you have now done is set decimal places to 9, which represents a floating decimal. Let's work through this problem now. You invest $100 today at 10% compounded annually. How much will you have in 5 years? You have learned how to do this using the formula, but now we'll see how to solve this problem using the calculator. And we are going to use this set of functions, which represents the time value of money functions on the calculator. Here is what you do. Second, quit, just to set the calculator in your standard mode. And then second, clear time value of money. This clears the time value of money worksheet. If you don't do this, then the calculator remembers what you did last time. Then you hit 5n. N stands for the number of periods. In our particular case, we have 5 years, which means that n is equal to 5. 5n, and the display then will be n is equal to 5. Then you say 10 IY. So this is saying that the interest rate per period is 10%. Notice that here you are entering the percent as opposed to the formula earlier where you entered a decimal. Then you enter 100 and PV. This is saying that the initial investment is 100. 0 payment, that means that over the 5-year period, time 0 to time 5, in between you are not making any payments. So this is 0. And then you compute the future value. That will give you this number. We have a minus because the calculator assumes that the future value will have the opposite sign relative to the present value. If you put in plus 100 here, then at the end of 5 years, the calculator assumes that you are taking the money out. So it will give you minus 161. If during entry you had put in minus 100, then the calculator would give you plus 161. Now let's look at a situation related to non-annual compounding. What we have done so far is talked about compounding once a year, but compounding of interest can happen more than once a year. Say you invest 80,000 in a 3-year CD. This CD offers a stated annual interest rate of 10%, compounded quarterly. How much will you have at the end of 3 years? How many periods do we have in this case? 3 years, and in each year we have 4 quarters. So the number of periods is equal to 3 times 4, which is equal to 12. What is our initial investment or present value? That present value is 80,000. What about the interest rate? If we are using 12 periods, then we need to look at the interest rate for each period. The stated annual rate is 10%, which means that the interest rate per period must be 10 over 4, which is 2.5. The payments here are 0. You can then simply compute the future value. The answer you should get using your calculator is 107,591. You could also solve this problem using the formula, and the way you think of that is as follows. Your future value at the end of 12 periods, remember 3 years means 12 periods in this example, is equal to the present value, which is 80,000, into 1 plus the interest rate. Now the interest rate has to be the interest rate per period, which is 0.1, that's the 10%, divided by 4 because we have 4 periods in a year, and then raised to the power of the number of periods, which is 3 years multiplied by 4 periods per year. And when you do this calculation, you should get the same answer. Let's see if you can solve this problem. The correct answer is B. What we have done here is shown the working using the formula, but you could have done this also using your calculator functions. And just to make sure you've understood the calculator function well, let us do it together. The number of periods here is equal to 365. Why? Because we just have 1 year, but we are assuming daily compounding. So every day is a period. The interest rate that you will have to plug in is equal to 4%, which is the stated annual rate. We put this in as 4% divided by 365. That's your return per day. And then the present value is equal to 3 million. The payments are equal to 0, and the future value is what you have to compute. If here is what you should get. Moving now to continuous compounding. We have seen an example with annual compounding. Then we talked about quarterly compounding. We have also seen daily compounding. if we keep increasing the number of compounding periods until we have an infinite number of compounding periods per year, then we say that we have continuous compounding. The formula for continuous compounding is given right here. The future value at the end of n years, now keep in mind this is the number of years, is equal to present value into e, this is the mathematical number e, to the power of r, where r is the stated annual rate. It is also sometimes called the continuously compounded rate, multiplied by n, which is again the number of years. An investment worth 50,000 earns interest that is compounded continuously. The stated annual interest rate is 3%. What is the future value of the investment after 3 years? Using the formula, the future value at the end of 3 years is equal to 50,000, which is the present value, multiplied by e, which is right here on your calculator, that is really e to the power of x. So into e to the power of r, r is the stated annual rate expressed as a decimal. So 0.036 multiplied by the number of years, which is 3. So the way you do this on your calculator is as follows. First thing, just multiply 0.036 into 3, then hit the second button and e to the power of x. That will give you an expression for this, and then multiply by 50,000. When you do the calculation, here is what you should get. Here is an important concept building exercise. Assume that the stated annual interest rate is 12%. What is the future value of $100 at different compounding frequencies? And then what is the corresponding return? I'll do the first one for you. If you have annual compounding, then at the end of 1 year, $100 must become 112, which means that the return is 12%. What if you have semi-annual compounding? Will the return still be 12% or more than 12%? Hopefully you recognize intuitively that the return will be slightly more than 12%. And given what you've learned over the last few minutes, I want you to fill this table out before you move on. If you've done things correct, here is what you should get. Notice that as we compound more often, the future value becomes a little bit higher. When we get to daily versus continuous, the number is almost the same. If you go to the third decimal place, then you will notice that the return using continuous compounding is a little bit higher, but at 2 decimal places, it is essentially the same. So the return keeps getting better as we compound more often, but it doesn't become a lot better. Note also that if you have 2 banks, A and B, Bank A tells you that they will give you a return of 12.5%, but there is only annual compounding. Whereas Bank B gives you a return of 12% and the return is compounded daily. What is better? Even though 12.5 looks higher, but you know that if your return is stated as 12% but then is compounding continuously, effectively you are going to get a return of 12.75%. So the offer from Bank B is actually better than the offer from Bank A. And this brings us to the concept of stated versus effective rates. In the example that we just saw, the stated rate was 12% across the board, but the effective rate depends on the number of compounding periods. When we have discrete compounding, then the effective rate is calculated using this formula. Let us do this for one of the scenarios. The effective annual rate is equal to 1 plus the period rate. Let's say that we are doing quarterly compounding. Then the periodic interest rate is equal to 12, which is 0.12 divided by 4. So that would mean that the periodic rate is 0.03 or 3%. We raise this to the power of m, that's the number of periods in a year. If we have quarterly compounding, that would be 4, and then minus 1. A lot of people get confused about this minus 1, and the idea is actually fairly straightforward. If you look at this part of the expression, essentially we have 1.03 to the power of 4, which is telling us how much $1 will become at the end of 4 periods, each period being a quarter. $1 is going to become 1.1255, but this is not a rate. To figure out what your return is, you need to subtract the original $1 that you invested, and what you are then left with is 0.1255. So that is your effective return, and expressed as a percent, this is 12.55%. If we do continuous compounding, then the effective annual rate is e to the power of r. R is the stated rate of 12%. E to the power of 0.12 minus 1. And when we do this, we should get 1.1275. That's the e to the power of 0.12. And in case you're not familiar with this on the calculator, you plug in 0.12 and then second and then e to the power of x. That will give you this number, minus 1, which will give you this number, which is the return expressed as a percentage, that is 12.75. Moving now to the future value of a series of cash flows. And first, let's just understand some terminology. An annuity is a finite set of level sequential cash flows. Level means equal, and sequential means that the cash flow is happening at equally spaced points in time. So an ordinary annuity is one type of annuity where the first cash flow occurs one period from today. Let's say that you receive $100 1 year from today, another $100 2 years from today, and then another $100 3 years from today. So this is an annuity. The payments are level because you are getting $100 each time. They are sequential. You are getting payments at 1 year periods. And the first payment is 1 year from today, which means this is an ordinary annuity. With the annuity due, the first cash flow occurs immediately. So if you have 100, 100 and 100, this is an annuity due. A perpetuity is a set of level, never-ending sequential cash flows with the first cash flow occurring one period from today. Here is an example of a perpetuity. The first cash flow is happening one period from today, and then every year you receive $100, and this goes on forever. Now let's look at the concept of equal cash flows, which is also called an ordinary annuity. Say you have an ordinary annuity with A equal to 1000. A refers to the annuity payments. In this particular case, we have 1000 over a 5-year period. The interest rate is 5%. We have 5 years. And what we are asked to calculate is the future value at the end of year 5. The brute force way of doing this is to simply take each cash flow and see how much each of these will be worth at the end of 5 years. This cash flow of 1000 at the end of 5 years is obviously 1000 at this point in time. The 1000 that you receive over here will be compounded one period. So this would be 1000 into 1.05 compounded once. This is going to be 1000 into 1.05 squared. This is going to be compounded 3 periods. This is going to be compounded for 4 periods. You take all these numbers, this, the number that is compounded for 3 periods and 4 periods, and you add them up, and what you should get is 5,525.63. there is a formula that allows you to calculate the future value. And actually, on the next slide, I'll show you how to do this on the calculator, which is what you should be doing on the exam. But here, I'm just introducing the fact that there is a formula, and at times you can get something called a future value annuity factor. So let's understand what this means. We have the same annuity. Each payment is 1,000, interest rate is 5, n is number of periods is 5. So same scenario. The future value at the end of year 5 can be expressed using this formula. A is 1,000, and then 1 plus R, 1.05, this is the interest rate, raised to the power of 5, minus 1 divided by the interest rate, which is 0.05. This number in here is called the future value annuity factor. If you do the calculation, you should get 5.5256. So this is the future value annuity factor. To come up with the future value, you take the annuity payment 1,000 and multiply it by the future value annuity factor, and you will get 5525.6, which is the same answer that we got on the previous slide. On the exam, if you are given the annuity number and the future value annuity factor, you simply need to multiply the two numbers to get the future value. And finally, let's see how we do this using a calculator. And this is the method that you should use on your exam. We plug in n equal to 5. That's the number of periods. The interest rate per period is 5%. So plug that in. Present value is 0. That's because you are not making any investment at time 0. The first cash flow is happening 1 period from today. The payment is 1,000. That's the equal payment happening at the end of every period. And then you compute future value, and the answer that you should get is the same as what we've seen on the previous two slides. You should get 5525.6. And again, this is what you should do on the exam, because this is the fastest method and doesn't require you to memorize the annuity formula. Now I want you to work through practice question 6. So either you can use the formula and get this answer, or what you can also do, and the recommended method, is to use the calculator. So let's look at what we will plug in the calculator. Notice that she is depositing 24,000 a year for 15 years. So n is equal to 15. We are told that the interest rate is 12%. So I is equal to 12%. The present value is 0 because nothing is being invested at time 0. The payments are equal to 24,000. And then we compute the future value. When you do this computation, what you should get is 894,713. Try to solve this practice problem now. The correct answer is C. And if you think about it, we are given the annuity. So the A is given, which is essentially the payment. And if we know the future value annuity factor, which is 21.664, then to come up with the future value, all you need to do is multiply 120,000 by this. You don't really need to use the interest rate. So in terms of least likely, the best answer is C. How do we deal with unequal cash flows? And this is a fairly straightforward concept. We want the future value at the end of year 5. Let's say that the interest rate is 10%. The way you need to do this is individually compound every cash flow, and this connects with the brute force method that we talked about at the start of this segment. So if you draw your cash flow, this is time 0, 1, 2, 3, 4, 5. This is your timeline. We have $1,000 at the end of year 1. So this is going to be compounded for 4 periods. So this will become 1000 into 1.1 to the power of 4. Then you have 2000 at the end of the second period. This will compound 3 periods. So 2000 into 1.1 to the power of 3. And then 3000 from here. This is compounded 2 periods. So 3000 into 1.1 to the power of 2. 4000 is going to be compounded just 1 period. And the final 5000 at the end of year 5 is what you have. So add all these numbers. That is your future value at the end of year 5. When you do the calculation, what you should get is 17,156.1.